All right, here we are, Quarkus Insights, episode 197, Understanding Jlama in Quarkus. And we've got a couple of special guests here. We've got Mario Fusco and is it Luciani? Is that right, Jake?
That's correct.
Good, I didn't butcher it too much. So welcome. And we got Demetrius and Holly here too. So hello, everybody. So tell us a little bit about last week. What happened last week?
Well, yes, we had this internal meeting. We spoke about the future of Quarkus, and in particular, these days I'm mostly working on J4J. I'm one of the two main contributors of the project. So J4J is key for all our ecosystem to integrate what we have with this generative AI world. And we were working hard to finalize the J4J 1.0 as soon as possible. Our goal is to have it out, let's say, around end of April or a couple of weeks later. But that's the deadline that we have, and let's see how it comes along. But it will be nice to have a stable release. Even though, to be honest, you can already use J4J even in production. There are people doing so already. We will probably do some minor changes to the API, and this is what we are waiting for, having this 1.0 out, because we may do some minor breaking changes in order to accommodate a new feature and a different design. But you can use it, and it's already pretty stable. J4J allow to integrate a lot of different model server provider, LLM-inference service. Basically, with the 99% of them, what you do is that they expose a REST API. So you do you interact through them with some HTTP request, and you get the response. And J4J provides a good layer of abstraction around this, and the Quarkus extension even better in some cases. I say the 99% of the cases because there is one notable difference, which is indeed Jlama. I don't know how many of you knows Jlama and who knows Jake. Jake, maybe you want to quickly introduce yourself.
Sure. My name is Jake Luciani. I'm chief architect at DataStax, where we worked on a database as a service. And my side project is trying to bring Java inference for LLMs as a option. It started off as a way for me to learn how LLMs work, and it's just kind of grown since there. So Jlama basically allows you in pure Java to run most of the popular AI models right on your laptop or PC, all in Java.
Okay, nice. So we
can ask quickly, what was the motivation to start Jlama, Jake?
It was to learn. I'm the type of learner where I like to go to ground truth to understand like how these things work. So in order for me to learn, I like to write the code. So it started off as very much a proof of concept. The quality of code you could probably see, it looks kind of like, I'm trying to figure it out, piece things together. But yeah, over time I just started adding more and more, like tokenizers and mixture of experts, quantization and all that stuff. So there's many layers to it. So trying to understand each one and write the code for it.
Excellent.
Nice. So yeah, we can start introducing a little bit more in details what Jlama is. As I said, normally what you do to interact with an LLM-inference service, either you have it remote, you interact with I don't know, OpenAI, ChatGPT, some ChatGPT model, or you have a local running server running on Llama. In all these cases, you do a REST call, an HTTP request to interact with this thing. The Jlama is a very notable exception because what it does is running the inference directly in Java, meaning that it can be on the same Java virtual machine where the rest of your application runs. So it is all in the same Java virtual machine. You don't have to perform any remote call in order to run this. Okay. Here we listed a few of the features of Jlama. There is a quite long list of supported models so far, and it's growing. And also the list of features is quite long. Maybe Jake, you want to clarify something about this? There is something notable? Or?
Sure. I mean, so most LLMs work the same way. The transformer architecture is very much like a solid code path. So for the most part, all these models work pretty much the same, like 99%. There's like this, 1 to 5% of like little tweaks, so like Llama does things in a slightly different way than Qwen 2, and so there's lots of little tweaks there which need to be supported, and then there's sort of like tool calling was a difficult task because every model integrates tool calling in a slightly different way. So tool calling is a very much like bespoke thing. It looks really cool when it works, but there's a lot of code to basically support lots of different models' way of calling tools. So there's just lots of different layers, but they all pretty much work the same. So all the models that Jlama supports are using the Hugging Face safe tensor format, and then inside of that there's float 32, float 16, brain float 16. There's float 8, float 4. So there's very much like all these different types of floats, and 99% of what inference is just matrix multiplications of the embeddings going across the layers of weights from the model. And then there's interesting things that you could do, like how can I break this up to basically run inference across multiple nodes? So me as a infrastructure engineer, that was something that was interesting to try and learn. A big benefit of this was, as Mario mentioned, using the new Panama vector API. So it actually, so Jlama works with Java 20, 21, 22, etc. And it's based on the new vector API, which is why it's so fast.
Jake, can I ask something? This mixture of experts support, is this it's a quality both of the model and the running infrastructure? Can you tell a few things how this works?
Sure. So an LLM is based on two or three major blocks. There, each layer is broken into these blocks. There's basically a attention mechanism, which uses the attention heads to basically look back at the KV cache, and there's also a basically feed forward layer, which is just a dense matrix multiplication and a activation function. What mixture of experts does is on that second step, before it goes through the feed forward layer, it basically takes the input and basically does a vector search across a set of routing tensors to basically pick which feed forward layer to use. So it's actually broken up. So there's a layer of layers inside of it, and each of those are experts. What this means is rather than having one gigantic layer which all input passes through, you can basically break it down into 8 experts, let's say, and on each feed forward pass for each layer, you can basically pick which sub expert to use. The value of this is the experts are more are less weights, so the inference runs faster, and it also allows you to basically have more expertise, right? So different experts learn more about different things, so it kind of routes it through.
Yeah, but
So
not all models support this mode, right?
Right. Yeah. The DeepSeek model and Mixtral are the two main ones which use it. But it was actually built by it was created by Jeff Dean at Google, who's one of the pioneers of like MapReduce, and so infrastructure engineers have kind of like gotten into this architecture and are starting to kind of change how these things work to make them more scalable. It's super interesting.
Okay, nice. So Jake clarified quite a lot how this thing works, but to me another important question is why we may want to do this. Okay, this has been already quite entirely anticipated by Jake. So Jlama allows to run LLM-inference directly in Java. It's based on the Java Vector API in order to do as fast as possible the 90% of the job, which is the matrix multiplication, of course. And it includes out of the box lots of features. Jake mentioned the biggest part of them. Another things that I found very useful during my experiments with Jlama is that it has a command line that is really nice to use. And one of the tools that this command line makes available is the possibility for model quantization. So in this way, you can make the model quite a lot smaller, and then also less memory eager and faster, and with a minimal, very minimal lose in terms of correctness. But as I said, the other question, in my opinion, on how this thing works and what it does is why we may want to do this. It's quite a common question, right? And in the past 2 or 3 months, I started using and integrating Jlama myself in my application, and I think I found lots of good reason why you may want to use this, why you may want to run LLM-inference directly in Java. First of all, it's very nice for fast prototyping, meaning that you don't have an external service server running somewhere on your own machine or remotely. Everything is embedded in the Java virtual machine, so it's super fast to set up a project and run it without any external server. And this is nice for prototyping, for instance. The fact that it doesn't require any REST call to an external server, it's probably an enhancement, a nice features also for security reason. It can be nice in legacy for legacy application to use the LLM as it was an internal libraries running inside the same Java virtual machine instead of querying an external service. Well, I used it a lot also for the observability to understand what's going on. Normally the LLM inference engine is just an external server, which is totally a black box. You call it and either it works or it doesn't. But since Jlama is pure Java code, you of course are also allowed to debug inside it if you want and check what it is doing. And this also improves the developer experience. Another important possibility, even if probably in very specific cases, is that if you think about it, you can in this way you can distribute your whole application, including the model and the code running the inference of it in one single jar. Okay, it means that since the model is in the jar and the model can be by far the largest part of the code, you will have quite a big jar. But normally you use relatively small specialized model, and in this case it may make sense. Okay, and since you have one single package for the distribution that contains everything, including the model, this could also allow some different age use cases. And the last two reason why I found Jlama interesting is that what happens often is that especially for complex application, you don't use a single model. You have different, for instance, for agentic AI use cases, you have different model with different goals and concerns and purposes. And maybe there are the biggest one, the most expensive one that they run on the proper server, but then you have a small auxiliary model to perform auxiliary tasks, and then could be models that could be served internally with Jlama. And finally, what happens to me is that I play a lot with different model, and when you change the model, you are also often obliged to change the prompt that you use with this so-called, even if I don't like the name, prompt engineering. So in this prototypical phase, there is a very strict relation between the model that you are using and the rest of your code, the prompt that you use to feed the model, and so on. So there is a very short and common life cycle between the model and the code, and everything in one single place. Once again, allow to fast prototyping. So this is my opinion. The reason to why it worth to make a try to Jlama. Yes.
Yeah, so we got a couple of questions here while you were talking. I didn't want to interrupt your flow. So can with Jlama, can you run multiple models at the same time like you can with the Llama?
Yes, with Quarkus, it's pretty easy to configure multiple different models. You give them a name, and to each AI service that you use. In that case, since you don't have one single model, which is the default one, but you have multiple models with different name, then it's enough for each AI service that you configure to mention the model name that you want to use with that specific service, and you are done.
Kind of just like you would do with a Llama, right? You wouldn't even touch your code, just configuration, right?
Yes. Yes, just configuration. And again, the only thing that affects your code is adding a property to the AI service annotation in order to declare which model you want to use with that service.
Yeah, and there's one more. So there's one more question. Juan was saying that he's been playing around with a Llama with containers and MCP, Model Context Protocol, and he was thinking of integrating everything with Docker Compose, but would using Jlama make that integration a lot easier? I don't know if there's enough in there for you to answer the question, or if you need clarification.
Yeah, I mean it works fine. So that would definitely be easier than Docker Compose. If you're going to use something other than Jlama, like you wanted to use Ollama, there's a great project called testcontainers.org, and that project allows you to basically kick off Docker containers as part of your Java test suite. So if that's something that you wanted to roll in, but another thing that Mario mentioned is for basically running your test suite, it's very nice to just be able to call out to Java code without having to spin up lots of containers to test your agent code.
I wonder, because they mentioned MCP, in this case, I assume MCP will be like the client side of it, with the model using the client side of it to call out to, I don't know, functions or other things. So is this actually, has this been tested, or you guys know?
I
believe with LangChain4j, you can both build MCP servers and call them. So it should be possible to do both, as far as I understand. Could be
This
wrong.
actually lives in Quarkus, right? Yeah.
I honestly, I didn't try this use case, but it's a good idea. Yes, I will give it a try. I don't see any reason why it shouldn't work, but the devil is in the details, of course. So I will give it a try.
Cool, thank you.
Okay.
No more questions at the moment.
Okay, so in reality, the other question that I hear a lot these days, and this is my personal response, or even my personal rant, if you allow me, is that well, why don't we do this everything in Python? Why you are bother at all? You bother at all using Java? All this Gen AI stuff is done in Python. Why even Quarkus? And my answer is that okay, but I'm not a data scientist. I mean, I don't work on the preparation of the model. I just take the model from hiking phase, for instance, as Jack mentioned it, and I use existing models and try to integrate it with my existing application that not only are supposed to use this new generative AI cool feature, but they only normally have to support the, let's say, boring feature of the enterprise world that are transactions, security, and scalability, observability, and you can name tens of them. And probably Java is still the best word to do all this stuff. So again, if you are a data scientist, I understand that you want to do this in Python, and to be clear, it's not even Python. Python is just a thin DSL layer on top of tons of C math libraries, but that's a different story. But if you like me, if you are like me, if you are a Java developer that are asked to integrate a model made by someone else in your enterprise application, well, still I believe that there's no better ecosystem to do this than Java in general, and the Quarkus and the LangChain4j extension, and Jlama if you want.
Yeah, this is a great point, and this is one of the reasons why I wanted to promote this project. You know, there's another project that I'm involved with called Vector, which is vector search engine written in Java. The sort of AI ecosystem for Java with Quarkus and LangChain4j and JVector and Jlama. We're building this like suite of pure Java tools for Java developers to basically jump into AI, rather than being like, okay, first thing, learn Rust and learn Python, and then, you know, like switch everything to that. It just doesn't make sense. So trying to build a AI ecosystem for Java, I think, is one of everyone's core goals here.
Are we going to talk a bit about performance? Because I'm sure this is in many people's mind, like how this compares to other.
Yeah, we will be getting there very quickly.
Okay.
Because yes, it's one of the main open thing, of course, and the biggest question. So yeah, before going to performances, again, the second part of this presentation will be basically all around performances. I just wanted to give you the feeling of what it means to integrate Jlama with your Quarkus and LangChain4j application. So LangChain, as you know, there are lots of different extensions for the different kind of model server that you may want to use. There is an extension that is made for LangChain4j and Jlama, and then you bring in also the Jlama libraries with these, and optionally also the Jlama native library. And in this case, you have to use a classifier to specify the operating system where you are running your application. And then in the Quarkus Maven plugin, you need to enable the use of the Vector API up until at least it will be in a preview version as it is now. My understanding is that the Vector API should be probably finalized and no longer a preview feature in Java 25, but they are still working on it, so let's see. But anyway, up until the Vector API is a preview feature of the Java virtual machine, you just need to enable this. in this way. And then, as I was mentioning, you can simply configure your the model that you want to use in Jlama inside the application properties file of Quarkus. And yes, here I configured a relatively small one. But as I said, you can have more than one and use with different name and use them with different AI services. And the other nice feature is that, okay, I configured this model. Probably I don't have the model on my local machine when I start working on it. What happens is that the very first time that you compile your application, the Quarkus extension and Jlama looks for this code, and either you have already downloaded on your machine, or it will do the download automatically, and then you will have there, and you can use also for the subsequent runs, of course. Okay, and then as I said, I started using quite a lot Jlama in a few example. What I wanted to give you is a few pointers for the example that we have. So if you are interested, you can try this at home. So I started with a very simple summarizer service. What this thing does is exposing a REST API and allows you to scrape to download the content of a website, of an article maybe, or a wiki page, and then extract the text, and then it sends the text to an AI services served with Jlama that just does the summarization. So the code is no more than what I'm showing you now. It's super simple, and this is the result of our example that I ran. So I sent to my REST endpoint the link of this InfoQ article, and I had this nice summarization of the article. And if you want to give a try to this example, it's on my GitHub. So the link is there. You can play with it. Maybe you can try with different models, because as I said, what Jlama allows you and makes it possible is that switching between different models is super simple. Every time you try a new model, if you don't have it locally, it's downloaded automatically for you, and and you don't have anything else that name the new model inside the application properties file. Another thing that we have is that we did this workshop that covers the whole Quarkus along Chain4j features and capabilities. There are lots of examples. This is done in steps. As you can see, all the steps uses ChatGPT basically. But what I did is adding one last step to do exactly the same thing that you tried with the step above, but using Jlama. So in this latest step of this workshop, you can also do exactly the same thing with Jlama. And another nice thing that we did, mostly Eric did, is this Parasol demo, which is, Parasol is our fictional insurance company when we have claims of car accident. And of course, you have this very user-friendly chat assistant made with an LLM. And what I did is that, okay, this was based on an Jlama server. I wanted to give it a try also with Jlama. So if you go to this other website to this other GitHub project. There is this Parasol demo, and optionally, and by default it runs with Jlama, but optionally you can run it with Jlama. In order to make it run with Jlama, one thing that I did is that this application use a quite big model, because it is a Granite model that has been fine-tuned with the with knowledge of the car insurance world. So it is a fine-tuned model. I wanted to use the same model, which is quite big. So what I used is that other feature of Jlama that I was mentioning before, which is the quantization, that allows me to make the model a lot smaller. In this case, the quantized model is just 31% of the original one in size. And once I've done this, I've been able to integrate this model inside this Parasol demo app. So yeah, I did this quantization. I uploaded the model on my personal Hacking Face repo, and then I linked the repo here into the configuration in the application properties, and everything works as I mentioned it before, even for this Parasol demo app. Okay, so what you do basically is that you if you want to give this a try, you run it with this Jlama profile, and of course remember to enable the vector, the possibility of using the vector API in case you run the jar directory. And then this is finally some answer to Dimitri's question about performances, and maybe Jake, you want to take this?
Sure, yeah. Yeah, so going to that question, how performant is Jlama, and when should you not use it? It's really good at small models, obviously. So, anything like, 1 billion, 2 billion, 3 billion parameters, it works great. Once you get above 7 or around 7, it starts to slow down. So the main issue is, since we're not using a GPU, the main limitation here isn't actually compute. It's actually the speed of your memory bus, because each time you're basically doing a pass through the network, you have to take all of the model weights and push it through the CPUs. So you can see here, like, small 1 to 2 billion parameter models quantized are like less than 5 gigs. And once you get above 7, you start to get into like 5-6 gigs, and like 10-12 is when things start to get slow. So, if you wanted to take some kind of estimate of like how slow is too slow, it's kind of changed now with models that think during inference. So this argument doesn't really work anymore. But in theory, humans read like 5 words per second, 250 words per minute. So that's about 200 milliseconds per token. So if you go to the next slide, I could show you that, so just a test of the upper bounds of this, a large model, a 7 gigabyte model, which is about 8 to 10 billion parameters at Q4 quantization. So like plain Java and threads does about 2 to 3 tokens per second. The Panama and threads does 5, just below 5, and and native SIMD, which is just an NFFI extension for the matrix multiplications, is slightly faster than Panama, and that gets us to 5. But it's like, how can we make this better? So the thing I've been working on the last few months is sort of looking into like how can we start to use the GPU, because CPUs are great. You can if you have like large servers with 64 CPUs and 128 gigs of RAM, that's great. You can basically run lots of inference. But as I mentioned, it really depends on how fast your memory is, and nothing is faster than the GPU memory, which is why it's so hard to get a GPU that has more than a few gigs of memory. So having a GPU card that holds 7 gigs on its own is hard. But with Max, it works great, and with larger consumer grade GPUs, it works great. The problem is GPUs in Java aren't really a thing yet. So if you go to the next slide, there's a bit of what are the options here? There's Project Babylon, which is great, but it's not nearly done yet. It's barely started. So who knows when this will come out? And the same approach I've taken with the vector API. I have this Jlama native, which does the matrix multiplications in C. So there's one external function call. If the Panama API as it works through its bugs. So we need kind of the same thing for GPUs. The plan is that eventually one day it'll use Project Babylon, and that'll be great. There's also Tornado VM, which looks really cool, but it's kind of a heavy lift because you have to kind of like use their suite and sort of augment your JDK with it. I believe you also have to run it through their tool. So it's not really like a great Java experience. The great Java experience you want is like, I just download a jar and then all of a sudden it magically works. So there was someone on the mailing list or in the discussion group that threw this random idea out. And it was like manna from heaven. Because it like, I was like, this would be a great idea. So I've been spending the last few months trying to get this to work on the side. And if you go to the next slide, basically the idea is like the web browsers have GPU support. Google has the fastest one. It's called Dawn. It's a standalone project, and it's basically just a shared library. But the shared library works on Macs, Windows, and Linux. So it's sort of a portable runtime that you can just use. So what I did is figured out how to hook for that matrix multiplication. So basically, when the model loads up, it loads all the weights onto the GPU, and it does some of the work in Panama and some of the work on the GPU. And the effect is like a 5x improvement on this relatively large model. So this is kind of like, I don't think anyone's really tried this before, but it seems to work really well. This is what I've been working on. It's not yet released, but there's a PR up. It only supports float 32, so I need to add like quantization, and so there's a bit of a long road. But this is really exciting because it sort of unlocks this, next level of integration in terms of speed.
On that, we have a question. Any thoughts on tapping into the CLib that Python uses for the GPUs?
Yeah, so I mean, there's lots of projects which use basically all Python or C libraries. There's I'm trying to remember there's a project for AI in Java. I think it's like, I'm trying to remember what it is, but they basically offload like all of it to C. You can also embed like, Llama.cpp. The goal of Jlama, though, was to try to do this as much as Java as possible, and eventually all of it. So as I mentioned, the only thing this is doing on the GPU is the matrix multiplication. So everything else that goes on is all pure Java. So I'm trying to keep it as pure as possible. So effectively, what this does is give you basically what the questioner described. I'm just hooking into this one engine to perform this one action. If you wanted to go full GPU, which is what these Python libraries and like Ollama does, for example, is it basically builds a graph of basically operations, and it offloads the whole execution graph off to the GPU. So it does like every step. So what this is doing is like some steps on CPU and some on GPU, but you still get a great boost in terms of
what do you have sort of metrics for, like what the difference is in performance between this approach with just using the GPU for the matrix multiplication and something that's using GPU?
If you use the GPU for everything, so it never leaves the GPU, you get like 70 tokens a second for this model. So I guess the ultimate thing, which is kind of what Project Babylon and Tornado are trying to approach, is like, let's write in Java and that sort of runtime operation graph of execution tasks, which is kind of like an asynchronous plan, and then execute. That plan gets converted into either OpenCL or CUDA or RTX, and basically gets pushed to the GPU. So that's kind of like where the future is. But for now, it's like this is a great way to kind of use pure Java with a little bit of GPU, which is, I think, pretty cool.
Very nice. So do you maybe have some demo for this, Jake? Do you want to share your screen? Or?
Sure. Let me pull up my, okay. So just to give a quick demo of.
Yeah, maybe if you can make the font a little bit bigger, it will be helpful. Thanks.
Okay.
Yep.
Is that good? Cool. So this is the CLI that comes with it. So you can just run one of the models, and you can just chat with it. So this is a small model. This is just using CPUs. So it's very fast with pure CPUs. What I'll show you now is what happens when you run a big model. Hang on, I gotta get my command so I can force it to use the Panama and run this big model.
The CLI doesn't happen to be written in Quarkus, does it?
No, that's something that you guys can add. So this is just running a completion on the model, and you'll see it's taking a long time to load all the weights into memory. Let's see if I do. You'll see, right? It's like 13 gigs off heap. It's taking a really long time.
What kind of hardware are you running on?
This is a 24 core CPU. I'm using 12 of the cores because SIMD only gives you SIMD on less than all of them. It's usually half. So if you look there, so I just ran it. It did 4 tokens per second, which is kind of like, which kind of goes back to that graph I showed. What I'll do now is I'll just make it run on the GPU. As I mentioned, this only works for like full float 32, which is why the big model is just a really big GPT. But so here you're basically seeing it's basically offloading everything to the GPU. So here's my GPU graph. You'll see the memory is creeping up to 25. And you see at the bottom here, it's going like 4 gigs, 5 gigs. And then once it's loaded, then it goes. So that's using the GPU for the same exact task. And the only difference is the weights have been offloaded to the GPU, and the matrix multiplication is happening there. All of the tokenization, the execution of each layer, the normalization, the attention mechanism, all that stuff is still in Java. So that's basically the demo of what I was going to show.
Jake, did you try to compile to native with GraalVM so that the model is preloaded? So you...
Sure, yeah. So GraalVM will work as well, but you'll basically get the same performance as the SIMD tensor operation. So the new versions of GraalVM now support Panama. So GraalVM is on my list of things to do. But you're still bound by the memory bus of your CPU. So so it's not going to make it faster. The slowness just comes down to how big the model is and the speed of your bus. So if you have like fast DDR5 memory and you have PCI 5 and a high speed compute, the faster your hardware is, the larger the model you can run. But so that's why if you're using CPU only, you should stay below a 7 gig quantized model. So there's Jlama 2, there's so that this is another reason why quantization is so popular, and most of the Jlama models, I believe all the Jlama models are quantized, to make them as small as possible, and that's the reason why. So the smaller you can make the model, the faster it runs.
Got it.
Okay.
I actually have another question. In the case of the Dawn, what's the dependency there? Like what you have to use next to your Java app?
Oh, sure. So I could show like the Dawn. Where is the? Yeah. So this is a good. So like, there's the web GPU guide. So these executions, there's one from Mozilla, and there's one from Chrome. I tried both, and the Chrome one is better. It took a lot of work to figure out how to optimize this so that the web GPU pipeline was basically as fast as possible. But if you look at, I'm trying to find in my history, I don't think I have it anymore. But I had the, oh wait, is this it? No, that's Project Babylon. Yeah, here it is. Right. So to basically build it, so what I'm going to do is basically build a little GitHub project that checks out the latest Dawn and builds the shared libraries for it. So what you get out of Dawn is literally one file. You basically get a .so. So if you look, I have it here. There's lib web GPU DOM. So so basically, just like in Jlama native, there's a shared library for Mac, Windows, and Linux. This would also be included in the jar, so it just comes with it, and it magically just works on your system. So whether you're using a Mac, M1, M2, M3, if you're using Windows PC or using Linux, it's just going to work. So that was kind of the aha moment for me when I saw that suggestion. I don't remember who the commenter was, but someone kind of just threw this out there. It's like, hey, it'd be cool to try using web GPU with Java to basically support the GPU. And I think it has legs.
Nice.
Yeah, Jake, if you wouldn't mind just throwing the links that you just showed in our little backstage chat, and I'll give them out to people.
And if you could zoom in and make your typefaces a little bit bigger as well. I think there's a bit of network slowness, which is downgrading the video quality.
Okay. Let me get to...
Yeah, the rule of live streaming basically is that the font has to be 18 times bigger than seems reasonable.
Okay, I put the thing there.
Thanks. Okay, cool. Are there any other questions? No?
Nope, not from the audience. So we got about 3 minutes here to wrap up.
So yes, what can I say more? I mean, I've been introduced to Jlama not many times ago. We were at Devox Belgium last October, so it's just a few months, and play a lot with it and have fun. And it's again, I found it very productive, especially for my experiment. I gave you a few pointers on how you can try this, and I invite you to give it a try, and of course to submit your feedback. That's all I have.
Yeah, please like and subscribe.
Yeah,
Okay.
very cool project, and like I said, I've played with it with the parasol thing as well, and it works really, really well. So,
and I think it would be interesting as well for like disconnected scenarios where you have your app with your model all bundled together. Yeah, a good thing.
Yeah, it works really great for classifiers. To basically detect like spam, for example. It's a great embedded use case. It's also great. Like I used it once because I was working on an app that didn't have any validation of the date field. So it didn't like force dates to be a specific thing. So I found this tiny model that ran super fast, and all it did was take like a random string, which included a date like February 3rd, 1972, with like some stuff in between, and it turns it into like a formal date structure. So like use cases like that, there's a lot of things that don't need to be like AGI to use models. It can just be very simple things that make it easy to do things that would require a lot of code.
That's really, really cool.
Nice.
Yeah, I can envision like car operating systems too, like because Quarkus is so small and fast, you embed the things and you can deploy it like right into a car, and you can start talking and chatting with your car, have it do stuff in your car.
Exactly. Yeah, and for tool calls, there's some really small models that are really good at taking instruction and calling a tool. So you don't need a giant model to basically build something that you can just kind of give it a bunch of tools and ask it to execute them and summarize.
Mini agent.
Yes, it's it's the general trend, one of the main trend now, meaning that instead of having this gigantic model that knows everything about the human knowledge, you have some very specialized model, and then they are smaller, they are more much less expensive, so also let's say more environmental friendly, which is important, and you have even better result because they are specialized model, and since they are not so big, it's pretty easy to have it in the embedded system. Like for instance, cars could be a good example. So
And
I see a lots of future on this.
yeah, if we do Quarkus for cars, we should call it Kit, like Kit from Knight Rider. Only instead of a K, it can be a Q.
Okay, that's a great idea. We already have the name. We already have a great name, which is the 50% of the job. So
Yep. Start with the
nice.
name, work backwards to the implementation.
Yep,
Okay.
that's our marching orders for 2025 now. We will have Kit by the end of the year. All right. Well, thanks everybody, and thanks Jake for taking the time out to come on in, and thanks everybody for watching and listening. And have a good rest of your day.
Thanks, folks.
Thanks so much.